Hey everyone, this is Dr. Walker. Let's look at an example from video 92 on the Doppler effect. It says, a car is traveling at a speed of 25 meters per second towards a motorcycle traveling at 15 meters per second in the opposite direction. The driver of the motorcycle hears the car's horn at a frequency of 113.1 hertz. Assume the speed of sound is 343 meters per second. That's the speed of sound at 20 degrees Celsius. Part A. What is the frequency of the horn as heard on the car? So all we have to do is figure out who's the source, who's the observer, and what are the speeds. Well, it said that it's the car's horn. So that means the car is the source. So the car is the source and the motorcycle is the observer. So S for source, O for observer. So that means that the speed of the car, we're going to call it Vs. And the speed of the motorcycle, we're going to call it VO. And then 343, that's the speed of sound. That's just V. It says the motorcycle hears the car's horn at a frequency of 113.1. So that's the frequency observed by the motorcycle, by the observer. That means that this is F0. And now we can go ahead and solve for the frequency as heard on the car. The car is the source, so we want to know the frequency of the source. So I wrote down the equation that we learned in the video, and all we have to do is plug and chug. We're looking for Fs. So we need to go ahead and multiply by the reciprocal. So Fs is going to equal Fo times V minus plus Vs over V plus or minus Vo. The car and the motorcycle are traveling towards each other. We said in the notes that we use the upper sign if we're traveling towards each other. So we're going to use the minus and the plus. We're using the upper sign in each. And now we go ahead and plug and chug. 113.1 times 343 minus 25 over 343 plus 15. Do we expect a frequency that is higher or lower than 113.1? We know that when the vehicles are moving towards each other, they're going to hear a higher frequency. So the frequency of the source should be lower than what is heard. And indeed, we get 100.5 as the frequency of the source. Now let's look at part B. After the car passes, what is the frequency of the horn as heard by the motorcycle? So now we're looking for the frequency of the observer. And we know the frequency of the source hasn't changed. And now we want to know what happens when they pass each other. So that means now they're going to move away from each other. So we're going to use the bottom sign in both the numerator and denominator. So we will have V minus V0 or VO divided by V plus Vs. We're using that bottom sign. So we're going to plug in 100.5, the frequency of the source, times 343 minus 15 over 343 plus 25. What do we expect to hear this time? A frequency that is higher or lower than the frequency of the source? We're moving away, so the frequency appears to be lower. And indeed, we get 89.5 hertz. So that was an application of using the Doppler effect equation to figure out the observed frequencies.